Woohoo, we're live. This is Math 40, Section 4.1, Systems of Equations, Part 2. And we are in the middle of looking at what happens when we graph two lines at the same time and seeing how they interact. On the previous page, we got these two equations, y equals x minus 2, y equals 2 minus x. And we discovered that they did have a point in common. And so from this, though, this is a lot of work. And we got lucky. The third point down was the one it matched. You can imagine there are a lot of graphs and a lot of lines where it doesn't go that easily or that quickly. And so the next technique we're going to talk about is how to use graphing to help you find these shared points. So what I will do is I will copy from the first page the two table of values. So this is y equals x minus 2. And we got the points 0, -2, 1, -1, 2, 0, 3, 1, and 4, 2. And for y equals 2 minus x, I've got 0, 2, 1, 1, 2, 0, and that was it. So we've got these two table of values, two different lines. And so I'm going to look at all the points involved. Mostly I just looked at positive values for x. So that means I can put my y-axis really over here to the left, give myself some space to the right. And again, don't try this at home. If you're going to draw graphs, please use a ruler. As you can see, I got a little wonky there, but I am a professional, so I can get away with this. I shouldn't. I really should be using a ruler, but honestly, you hand me a ruler and suddenly rulers are flying across the room. I'm so clumsy. I could take people out in other houses. Truly, no one should arm me with a stick. So the other thing I'm looking at is I'm seeing the values of y. I've got 0, 1, 2, 0, 1, 2, -1, -2. So I want to make sure I have room top and bottom for positive and negative. So I'll go ahead and put my x there. If you're used to doing your axes in the middle, go for it. This one is fine. The only time you really have to worry is if you have very large numbers or very small numbers. Okay, I am going to mark out my graph. There's 0, there's 1, there's 2, there's -1, there's -2, 1, 2. Okay, so let's see. I've got 0, -2, 1, -1, 2, 0. There's 3, there's 4, 3, 1, and 4, 2. So this first graph is looking like it's right there. And what I'm going to do is, let's see if you guys can see this. I'll make this first graph will be the yellow graph. Can you see that in the video? Sorry. Ooh, I know. I have a very extensive lighting budget here. I have a lamp with 3 settings, which I think puts me, right there at the forefront of technology. So I'm going to, let's see, I'll draw this in yellow first. Oh, that's an interesting side effect. It kind of gets drawn in black when I draw it in yellow. So we can use colors to differentiate, or you can go ahead and just at the top or the bottom of the line, you can write in which equation is which. So there's my yellow graph. And then I've got y equals 2 minus x. And these points are 0, 2, 1, 1, and 2, 0. Now this is going to be my blue line. And the blue line is going to go right here. So it's kind of interesting that smearing is my friend today. Okay, so what was really important about this, though, is when we're all done graphing the lines, we can see that there is a single intersection. So Matt Damon is saved. This is a happy Matt Damon moment. And that point of intersection is the point 2, 0, which is the shared point that we saw on the front page. This is that shared point. They both go through 2 comma 0. So that is the system. That is the solution to the system. Solution to the system. So why am I less than thrilled about this method? Well, this method is great for visualizing what's going on, for having an idea that there is a solution. But why is this method of solving less precise? Well, the answer is it looks like 2, 0. And if we happen to pick 2, 0 in each of the table of values, we can actually see it happening twice. But if we're just looking at a graph, and I've graphed it, especially without using a ruler, how would I know the difference between 2, 0 and 1.90? It would look just like, they would look very similar. So this method mostly works to give you an idea of what's happening, to give you a picture of what's happening, and to get you into the ballpark. But if your answer actually is something like 1.89536, there's no way you could read that off a graph. So we're going to have later on in the chapter, we will have other methods that will help us get precise answers. So solving graphically, solving by graphing is going to give us the idea, kind of an estimate. So shall we try another one? Woohoo! Now, I am not in class with you, so I cannot force you to stop this, but what I would encourage you to do is to grab a piece of graph paper, pause the video right now, write down these two problems, the 2 lines, y equals x minus 2, y equals x plus 4. You see the brace around them. That brace is telling us we're going to work these together. And so what I would encourage you to do is pause the video right now, graph both of these on the same set of axes, and then come back, start the video up again. Okay, so I'll see you guys in a little bit. You guys start working, and then I will start working as well. I feel like I should sing the Jeopardy theme to encourage you to take a moment. Do, 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 do. Okay, so I'm going to assume that you've unpaused the video and you're ready to see my solution, just like I did above, although I'm pointing to something you can't see. So up there, I've got 2 equations, y equals x minus 2. Just because that one was, we already started working on it, and y equals x plus 4. So in each case, I'm going to set up, and you can set up, and we've talked about this before, a table of values. You don't have to use a table of values. If you want to use the intercept method where you find the intercepts, that's great. If you want to use the slope method where you start with the y-intercept and then use the slope to graph it, any method of graphing is fine. I'm just going to be using the table of values here just in case it gives us a little bit of extra insight. So if I got y equals x minus 2, x is 0, y is negative 2, x is 1, y is negative 1, x is 2, 0, 3, 1, 4, 2. I'm cheating because this is exactly the same. Ooh, I could add some light. Let me add some light. This is exactly the same problem, or exactly the same line that we had up above. Now, x plus 4, slightly new, 0. Y equals 0 plus 4, which is 4. X equals 1. Y equals 1 plus 4 equals 5. Now, these numbers are getting kind of big. So what I may want to choose to do is maybe try some negative x's. What about negative 1? Negative 1 plus 4 is 3. Oop. Oh my goodness. See, this is what happens. Don't let your teachers record videos and not drink coffee. I haven't had any coffee yet this morning, and look. So please make sure all of your teachers are well caffeinated before they turn on YouTube Live. It's up to you to avoid a tragedy like this. Okay. What happens when x is negative 2? Negative 2 plus 4 is 2. Negative 3 plus 4 is 1. Negative 4 plus 4 is 0. So we've got a whole range of y values. We've got a whole range of y values here. Let's see. My y's get pretty big. So if I'm going to fit them all in, I might put my x-axis kind of low to give a lot of space up on top. Here's my x. And my X's go pretty far in both directions, so I'm just going to put my y-axis right in the middle. And again, if you have a larger piece of grid paper, it doesn't matter where you put the axes. It's because you got lots of space. I'm just trying to make good use of this little square I gave myself. And then again, I will go for the yellow. Can you see this? There will be the yellow. Scooch this up a little bit. And the blue. You don't have to color code them, but I just figure in a video it might make it a little easier to see. And, you know, it would be brilliant if well, no, I'll have to work. I do have some pens I realized I could use for my next videos. We're going to be doing this for a while, so I will figure out how to do this. So my first one, my graph, well, to be honest, I already graphed it up here with the yellow one up there. So I could just use that graph, or just very quickly, I could plot the points. Let's see, this is 1, 2, 3, 4, -1, -2, -3, -4, -1, -2, -3, 1, 2. So again, in class, I mentioned that you do not have to put all the numbers in for the scale, just one per axis is what my requirement is. Different teachers have different minimum requirements. So mine is that you need at least one number on each axis, and as many more as is helpful. I'm going to go start plotting 0, -2, 1, -1, 2, 0, 3, 1, 4, 2. And they all line up along a line, which is really nice. Okay. There we go. I wonder if you can earn an Oscar for creative use of smearing in a video. A film. This is a film. I consider myself a director, a writer, and an actor now. Okay, so next up, I'm going to graph the blue line, y = x + 4. I've got 0, 4, 1, 5, and then we switched over and I was like, ooh, this is going to get really big. -1, 3, -2, 2, -3, 1, and -4, 0. So the blue line looks like it's going right there. And so my question for you, what solution will make Matt Damon happy? And the answer is, oh no, it looks like these two lines are parallel. Oh no. So it's oh no, that would mean no solution, which means that Matt Damon is stuck on Mars, which I think, you know, Matt Damon's probably not happy about that outcome. But, you know, the upside would be we wouldn't have to worry about saving him anymore. I mean, if we just left him on Mars and sent him some food every now and again. But do we know from the graph that they're actually parallel? And the answer is not necessarily. It depends on how good you are at reading graphs. I think a lot of people would look at this and say it looks like they're parallel, but they wouldn't necessarily know for sure. So the question is, how would we know for sure that they are parallel? Well, we would graph it and go, oh, look at these. They look parallel. And then I'm going to come back up here and I'm going to say, remember about y = mx plus b form? The number right in front of x is the slope. So here, my slope is, I just have an x, so that means it's 1 times x, so my slope is 1. Down here, I just have an x, so my slope is 1. Same slope. They're parallel lines. So there are no solutions. Which means that Matt Damon is very sad. This is gonna be super fun because anyone oops, sorry, you can't read that. Anyone who's just reading this without having watched the video is gonna come across that note and be like, "Why does Matt Damon care?" So, there we go. This is the end of page 2 of solving systems of equations graphically. So in this section, we're just gonna graph them and see what's gonna happen. In the next section, in 4.2, we're going to start using an algebra technique to solve systems of equations and find out whether Matt Damon gets saved or not. Woohoo! Turn into that. Same bat time, same bat channel.